Trigonometric functions and special angles, problem type 1. The trigonometric functions, sine, cosine, tangent, cotangent, secant, and cosecant, are defined for any angle between 0 degrees and 90 degrees nicely, and for angles outside of that by a process of iteration. Most of the time, the result of performing one of these trigonometric functions on an angle gives you a non-algebraic number. There are a couple of cases where the result is an algebraic value, and of those, most of them are easy to remember. They are 0 degrees, 30 degrees, skipping ahead, 45 degrees, 60 degrees, and 90 degrees. Or in radians, that's 0, pi over 6, pi over 4, pi over 3, and pi over 2. The pattern seems a little bit strange when you look at these angles, but the reality is that we are skipping two. The 15-degree angle and the 75-degree angle are also algebraic values. They're numbers that we can write nicely without having to rely on a decimal approximation. But they're a lot uglier, and most people don't remember them. So we stick with these 5, which you will be expected to know offhand. The sine of 0 degrees or 0 radians is 0. The sine of 30 degrees or pi over 6 radians is 1/2. The sine of 45 degrees pi over 4 radians is the square root of 2 over 2. For 60 degrees pi over 3 radians, it's the square root of 3 over 2. And for 90 degrees pi over 2 radians, you end up with 1. Which is a seeming random list of numbers. But if I write these values out slightly differently, a nice pattern emerges. Right? The square root of 0 is 0, and 0 divided by 2 is still 0. So 0 is the square root of 0 over 2. Likewise, 1/2 is the square root of 1 over 2. Root 2 over 2 and root 3 over 2 makes sense. And then the square root of 4 is 2, and 2 divided by 2 is 1. So the pattern here is 0, 1, 2, 3, 4, square root of that number divided by 2. Just remember that we have 5 special angles in degree or in radian. List them out in order, take the square root of the count, divide by 2, and that gives you the value for sine. Once you learn this pattern, you can reproduce this table incredibly quickly. And then cosine is the same list, just reversed. So we start with 1, and then root 3 over 2, root 2 over 2, 1/2, and 0 at the end. Once you have this pattern memorized, you'll be able to quickly answer a lot of questions and be able to work with rough approximations of real-world applications without having to rely on a calculator. In order to use these values in the applications, we also need to visualize our angle in standard position using a reference angle. So if, for example, I have an angle here, this angle perhaps, well, halfway around the circle is pi. A little bit more than that might be something like 7 pi over 6. Right? When you're thinking about reference angles, instead of calling this 7 pi over 6, you might call it 7/6 pi, which is just ever so slightly bigger than 1 pi. And the importance of a reference angle is that we look related to the x-axis. So 7/6 pi takes us here, which is 1/6 pi, pi over 6, beyond the x-axis. So 7/6 pi and 1/6 pi are going to take on the same values. The only difference is whether the sine and cosine will be positive or negative. Sine is positive above the x-axis, and cosine is positive to the right of the y-axis. Down here in the third quadrant, sine and cosine are both negative. So sine of pi over 6 is 1/2. It's in the third quadrant where we're going to get a negative value. Sine of 7 pi over 6 is negative 1/2. Same thing with cosine. Cosine of pi over 6 is the square root of 3 over 2. Because we're in the third quadrant, that's going to be a negative value, negative root 3 over 2.